Hi there, welcome back to my channel, and today I will show you the second video of my project series. So I hope you enjoyed the first video where I talked about a lot of different techniques by which you can explore the data and finally predict the data and put it everything in a dashboard. So after that series or after that video, in this series, the next video again will be about data science, where I will be showing you how you can plot histograms, how you can plot correlations, and then finally everything put together in a dashboard. And for sure, we will try to achieve some dynamic behavior. So make sure you are watching all of these techniques till the end of this video and gain maximum out of it. And before I move ahead and start showing you, don't forget to subscribe it if you have not already subscribed to my channel, and please do share so that you are sharing the information along with me. Thank you. Alright, so here we are in our data set, and this is an air quality data which is used in the R programming or as part of the R architecture or R studio. You will see this air quality data as part of an integral of the R system, and I have taken the data from there. And for you, what I'll do is I will put it into a easy to use or easy to download form in a Google Drive, which I usually do, so that you can use it. So what it has is some of these columns like ozone, solar, wind, temperature, month, and day. So it's basically on which day and what is a month, what is the temperature. So basically it's about predicting the temperature based on the variables like wind, solar, ozone, month, and day. So this gives a particular temperature and says this is the 7.4 is basically the value that they recorded for wind. Thus for solar rays, they captured the value of 190, and for ozone they captured the value of 41. Let me get a bit of a definition so that if you are really understanding in getting the definition, you can get it. So here is something which I have. Okay, let me paste special as values. So here is ozone, that basically mean or average ozone in parts per billion from 1300 to 1500 hours at Roosevelt Island. And then solar radiation, and wind is basically average wind speed in miles. And then temperature, so maximum daily temperature that they recorded in Fahrenheit at LaGuardia Airport. So that's basically a definition, and if you are interested in knowing more about it, you can basically type this and you will find more information in the Google about it. But what we really want is try to understand the impact of these three variables on the temperature based on how they recorded in a particular month or on a particular day. So let's go ahead and try to get this data inside Tableau. So what do we have is basically it's a CSV file. So I will click over here and click on air quality. So over here we have this column F1, which is nothing but a serial number. So what I'll do is I will click over here and hide it because it is having no use. Then another interesting thing with the ozone is it has identified it as a ABC, that means a string. So I need to convert it into a number so that I can use it for my analysis. So I'll go ahead, click on ABC and click on the number whole. And now as soon as I have changed the number, if you have observed, all the NAs have been converted into the null values, which is basically a property of the number values, that if it is a number it will be null, if it is a string then it will be NA. Let's see if there is anything else. So month is fine, day is fine, so we are good to go. But what is the treatment of null values over here? Because null values create a lot of problems when we analyze the data, and their treatment is required. And there are various ways by which data scientists or data analysts treat it. Either first thing is you completely remove it, that's number one. Number two is generally the technique which is used is using the average or mean or mean, median or mode after analyzing the data. Or they used some sort of a regression technique like a simple linear regression, or maybe a little bit modified based on how the data is behaving, and forecast the value of each null value and put it over there, which is like a slightly advanced technique of imputing the missing values. That's what the technical word is, imputing the missing values. For us, for this tutorial perspective, what I'll do is simply go ahead and remove it. So I will add the filter, click add, and first let me see in how many cases we have null. So in case of ozone and solar, we have null. Yeah, apart from that, if I just go down, I don't see anywhere else it is null. So I will simply go ahead and say click add and pick the ozone, and I will exclude the null. Click OK. I will add again solar, and this is a range of value. It's an issue. If I say spatial non-null values, got it? So if you are coming in sort of a situation, then this is how you need to resolve it. Click OK and OK. So now all my null values have been removed. And solar.r doesn't make a lot of sense. So what I'll do is double click over here and remove the solar. So now the values are properly coming, and the label has been changed properly. So the next part is to go into a sheet. All right. So once we go into the sheet, the very first thing I would like to do is understand the pattern of the data and then try to have an understanding whether this pattern is having an impact on the temperature, which is over here. But before we do that, one observation which I have is the month over here. So month is, sorry, the ozone is coming over here as dimension. However, that's not the case. So what I'll do is I will click over here and I will convert it to a measure. That's one thing. Or I can drag it and my ozone measure is now here. So both the option works for me. After that, once we have done that, what I need to do is I need to keep I can just go ahead and select ozone and come over here and show me, and if you see, I have an histogram. So once I click on the histogram, there is a sort of a bar chart that has been created for me, but this is different from bar chart because this is just based on one single measure. And if you don't know about the histograms, they are basically a statistical chart which represents the frequency under which a particular event has occurred. So for example, between this ozone 0 to 10, you have it occurred at 13 times. And over here between 10 to 20, you have it occurred between 34. So sorry, the 34 is a value that has been occurred. So on and so forth. And there is one null. I'm not sure why it is coming. Maybe there was a null value which probably I have not seen it in ozone, so I'll just hide it. And so that basically indicates the shape of the data, which is right now, if you see over here, is bit right skewed. But that's not how you generally decide whether this is the shape or not. Generally they try to play with the ozone bin. So what is ozone bin? Bin is basically this range which has been automatically created. So 0 to 10, 10 to 20, 30, 40, all of these bins have been created for us by default. So what I can do is come over here and click on edit. So suggested bin size is this. However, I can go ahead and change it to whatever I like. So for example, I like 5 and click OK. So still there is nothing much of a change. And if I just go ahead again and let's say this time I say 20 and again there is nothing much of a change. So when I'm increasing or when I'm decreasing the value, it does not really reflect a lot of change into a shape. So that means I can simply go ahead now by this structure, which I believe represents a better structure of looking at this particular data. Now if I have, let's say, this ozone, which is indicating that over it's basically a the right skewed chart which we are seeing over here. And if I create a new sheet and now try to do the similar stuff on solar and try to understand the shape, click over here, and solar, if you see, is completely opposite. It's basically bit left skewed in this case. So over here it's right skewed, and in this case it's left skewed. Again, you can play with the solar bin by going into the edit mode and changing the value as per your need. So for example, if I change it to 10, let's say, this is how it looks like. So I will press Ctrl Z or Ctrl Z to come back to the previous stage, and I can then play with something which is increasing. So 30 in this case, let's say. Again, there is nothing much of a change, but I believe the previous chart or the previous shape of the chart was reflecting the much better value. So over here, I think that's what it is. So it basically represents that values are condensed towards the higher side, and in case of ozone, the values are condensed towards the lower side. And so this is basically our solar, and the third is basically the temperature. And if I go ahead and create a histogram of this, shows us a bit of a normal curve, however slightly skewed towards left side, but overall it represents the normal sort of a curve. So I'll just go ahead and click on edit, and let's say I say 2 in this case. Yeah, nothing much of a change. Even I think 1 is better in this case because it's a temperature. Okay, so nothing much of a change. I think even 2 was representing the similar picture, slightly skewed on the left side, and we are seeing that mostly it is on the higher side of the temperature. So now we have understood the shape of the data, that about the temperature, about the solar, about the ozone, about whether it is a right skewed or a left skewed, which basically gives us an indication where most of the values are concentrating. The next step is basically to understand the correlation. And before I do, what I can do is simply create one more chart, and for the wind I can go ahead and create the histogram, and it looks like perfect, almost perfect normal chart compared to temperature, which is like slightly left skewed. So temperature, and this is wind. This looks like a very much a normal curve. If you don't know what it is, I suggest Google it. You will find countless articles or tutorials about it, which is pretty good before as compared to my explanation. But if you already know this, you understand that it's basically a normal behavior from the wind, which is pretty much on the lower side, having the same bars which is on the right hand side, which is an increased or the higher side. So after that, let's try to understand the correlation piece. So correlation, let's say, between ozone and temperature, because we are looking to see what are those things or what are those variables which are impacting temperature. So once you have understood the shape of the data, let's try and create the scatter chart to understand the correlation piece. Analysis, aggregate measure. So temperature is here, which basically indicates that temperature is increasing when there is some increase in the ozone. So what I want to really understand is basically by month. So if I bring the month over the color and change the color. Let's say edit, and let me take these three and make it a step of 5 because we have 5 months. So click apply and OK. So now if you see, we have this ozone is going high and temperature is going high, and over here ozone is low and temperature is also low. So seems like there is a correlation, and just to confirm that, what we can do is come over here in analytics and pick the trend line over here, which is like a linear, clearly a positive upward correlation. That means it is a very significant variable that we have for this analysis. So if I click over or hover my mouse over to this line, you can see the equation as well, that right now it is predicting the ozone in this case. But what I can do is basically swap it from here or press Ctrl W. So if I swap it, it will start predicting the temperature for me. So now you see the temp is coming as an independent variable and saying the particular value, which is I think it is 200,057 multiplied with ozone plus 69.3706, which is basically an unexplained the intercept, and the r squared 0.48796 indicates that it's relatively important variable, not very high, but it can be considered if we compare a couple of other variables. And p-value of 0.001 statistically indicates that this variable or this equation can be accepted, and we can start having the prediction within this range of the data to identify what will be the next temperature. So that's, we can say, ozone temp correlation, and then we try to do it with solar and temp correlation, and come over here, come to analysis, uncheck the aggregate measure over here, bring the month over here, and again go to color, edit color, and over here again I'll choose this stepped color. 5 is fine, click OK and swap it. So temp is over here, solar is here. Seems to be a correlation. As the solar is increasing, there is a slight increase, but there is nothing very significant which I can see when I look at the various months and the temperature and the values of the solar. If you see the shape of this data, it reflects that there is nothing very high correlation which is present. So to confirm that, again let's go into the analytics, bring the statistical linear line over here, and if you see this, even the statistical line is showing the r squared value, which basically indicates a contribution of the variable into the independent variable is 0.07, which is like very weak. If it is more towards 1, which is like 0.80, 0.9, 0.7, 0.95, then we can accept it. So here when we are thinking about our model or the statistical model, this particular property does not really reflect, or this chart basically indicates that solar does not really contribute into the temperatures, which based on the data that we have collected. So let's give it a name, temp, keep the same format, solar temp correlation. And now let's bring the another one, which is wind and temp. Okay, and come to show me and click over here, go to analysis, uncheck aggregate measure. So if I don't do anything right now, I can clearly see that there is a negative correlation. So if you look at this data points, this is indicating that it is going towards downward side, right? So if I bring the month information on the color and click on color, edit color, we'll do the same setting, Red, blue, I guess that's the one. If not, that's also okay. So that's the temperature showing us negative, that as the wind is increasing, there is a decrease in the temperature. Just to confirm that, again, we will go to analytics, bring the trend line over here, and it shows that there is a negative correlation. But again, if you see negative correlation, the value of temp equals to minus 1.19, which is basically indicating that as the wind is increasing, the temperature will be decreasing. But the R-square value again suggests that it's not a very important variable, or wind does not really contribute a lot in temperature. So this way you look at the R-square, and the p-value is less than 0.001. That means it suggests that this variable can be accepted. So it's up to us, based on then the subject matter expertise, or the person who is the business functional person or the SME can then help us decide whether we want to contribute it by doing some more experiment with the data, or predicting on the new data, and then basically come up with the entire model. So we have done this pretty much with every variable over here, if you see. So we'll give this a name, which is wind temp correlation. It's basically a visual correlation. If you see, it's nothing like I have used the Corel function, or CORREL. Yeah, that's the function. If I just go ahead and click on create calculated field and come over here, CORR, not CORREL. I guess it's in either ClickSense or ClickView, it is Corel. So here it is CORR, and it's basically two variables it takes. Here in this case they have given sales and profit, but it basically indicates that temp and solar, ozone and temp, and temp and wind. All of this you can basically identify the actual correlation value. So I really recommend, as an example or as an exercise for your home exercise or the homework, you basically use the Corel function, CORR function, core function, and try to identify the actual correlation value. So here I can see that it's negative, but what is that specific negative value, or the negative correlation value? It should be between -1 to +1. So suggest me what is that value, and write it in the comments if you can figure it out. Okay, so let's move on. The next thing I want to do is I want to somehow automate this so that I don't have to show 3 different dashboards or 3 different charts, like ozone, solar temp, wind, and then ozone temp correlation, solar temp correlation, and wind temp correlation. All of this thing, I really don't want to show it to my users. I just want that I give them the flexibility where they can select the ozone, solar, temp, wind, whatever variable they want, they can select it and then put it on the chart dynamically, without my need or without the developer's intervention. And they can also be able to change their respective bin size so that they can play around with it. If someone is really into statistics and really want to play around with this, we want to give them the flexibility so that they have all the power in their hand to do the analysis. So for that, what I need to do is basically the architecture for creating this thing lies in the heart of creating parameters and then attaching that parameter to a calculated field. So let's try to first automate the histogram. Okay, so what I'll do is I will click over here and click on create parameter and call this parameter measure. It will be a string because I want to select the name of the measure, and the name of the measure is nothing but the string. So I'll click on list because it will be a list of values which I want to give it to the user for selection, and name is the same name, ozone and solar, and then wind and temp. Okay, and after that click OK. Alright, and click over here, click on show parameter control. Once we show the parameter control, once you try to select anything, it will not change anything because we have not done any setting so far. So what do we do is come over here and click on create calculated field, and let's say selected measure, and over here we need to write a statement or a control statement which can pick the value from here and control the behavior of the of our calculation, and then accordingly update the chart. We will see how we can apply that calculation. So selected measure, we will use the case statement. Case is measure. In this case measure when, so when the value, when it's ozone, when user is selecting ozone, then populate the ozone field. That's how you should basically, if you are a beginner, that's how you should try to write your expression. When user is selecting solar, then the field should be solar. When user is selecting temp, then field should be temp. Else, that means finally it will be wind. Okay, and end. So if you see, my calculation is valid and I can click apply and OK. Alright, and what I can do now is remove this and remove this. I select my selected measure, click on show me and click over here. So once I do that, the measure is coming over here and selected measure is here. Selected measure bin is created, and now by default ozone is selected, but if I want solar, here is my solar chart which is now dynamic. Here is my wind. Oh, so this over here, this is a problematic thing, and if I try to change the bin size, if you remember at the start of the video how we did it, it's basically going over here and change the bin size by going to edit mode. But now if I do change the edit mode or change the bin size over here, it will be changed for every single different chart that I'm creating, or the histogram that I will be selecting with the help of this measure. So what do I need to do? Well, I need to come over here and click on create new parameter. Okay, and it's basically call it a bin size. Current value 11.9, that's okay. We want to give a range. Range should be 1 to 100, let's say, and 1 to 100, and step size should be 5. Let's give it like little bit high. I see that there were values which were beyond 100, so let's give it like 300 and click OK and click OK. So now the bin size is over here, if you see. So 5, or if I say 10, so there is 11 which is coming. And so what do we need to do in this case is we need to change the bin interval. So over here click on edit and bin size. So what I need to do is come over here on the parameter, edit, and so minimum, let's call it, we are already at 1. Step size looks okay, and current value to me doesn't look okay. So what I'll do is change it to just 1 and click OK. Yeah, now it is coming perfect, which I want. So bin size is 1 and there is a step size of 5, and then it's basically giving me what I need. And I can change, let's say, this to 5 or 10 because we have 1 already over there, so it is increasing. So if I enter 10, it will increase 11. So that's how I can basically go ahead and change the bin size for all of my values which are coming. So over here I need to give probably 20, and now the value is coming properly. So this is how you can basically automate entire thing, or all the different charts that we have created. So let's call it automated. Okay, and now if we are going to correlation, we will going to be using the similar sort of functioning that we have created. So temp, in this case, temp will be at the same place, but the selected measure over here will be something different, right? So come over here and click on show parameter control. So right now it is showing you the correlation between solar and temp, which is nothing but this, which you can see it's pretty similar. So if I go back, solar, ozone, and then wind. So this way all of my calculation or all of my charts are now pretty much automated, which I can then put it in my dashboard if I want. So click temp. Temp will be, so over here you have temp, here also you have temp, and you will see a complete fine correlation. So no point in using that. So what do we need to do finally for this case study is create one simple dashboard, bring the automated chart first over here. All right, no worries if it is coming like this, and then bring the, or I'll bring this as a first one because this looks much more attractive over here, and we will give it a name which is call it, oh, this is blank, I need text, so call it text. Air quality, New York air quality data analysis. Okay, we can change the font and everything, like right click on format text object, how we want the alignment and all of that sort of things about it. If I double click, select this, change it to something like 20, change the color to red over here, New York, or maybe make it like bold a little bit. Click OK, and I can drag it over here. So now you see we have this measure. We need to make sure that measure is changing both of these. So if I just try to select, let's say solar, it's just changing this, it's not changing it over here. So what I need to do is click on more options, and over here this parameter is, so I think this is doing the work basically, because it's not a filter specific to a sheet but a parameter related to both the sheets, so it should work. So let's try to change it. So yeah, wind is according to that, it is changing, solar it is changing, and ozone it is changing. One last piece, if you just have observed, it is not changing the value over here, which is ozone temp correlation. So what I can do is double click over here. It's saying the sheet name, but what we can do is we can from here try to see what we can do. So parameter measure, basically dash or a hyphen, and then temp correlation, click apply, and okay. So ozone temp correlation, yeah, ozone we have selected, solar temp correlation. So it has become much more user friendly now. And finally over here, the bin size is something which is problematic, so I think we need 1 as a bin size for this, which user can play around with it. Apart from this, if you want these things or these values to be somewhere else, like over here, bin size beside to that, create sometime an issue, but what I'm just trying to give you some of the options about how these things can work, but I think it was fine earlier. So Control Z, Control Z, Control Z, and everything is fine. Looks fine to me. So this is a simple air quality dashboard that has been created with the correlation with the histogram. Everything I am even giving them the R-square value, P value, as well as the equation of the line which is coming as a dashboard developer or as an analyst, and helping them understand how the change in temperature is happening based on the different measures that they are selecting. So basically making it more and more interactive for my user. So that's pretty much it that I have for you in this video about creating a dashboard for statistical applications like this. I hope you have found it useful, and I will meet you in the new case study or in a new project with some new type of data, and we will look at some more interesting features over there.